Welcome. Part 1, Lecture 11. Just only for information I write. Actually, it is there in the thumbnail only. Display you can see. Make a note. Yesterday or last class, I'll write here, somewhere here. See. Last class. You don't do see here. First you see here now. Last class. You should write it. We considered resolution of a force in any two given directions. They need not be perpendicular to each other. Randomly, or you can write any two randomly given directions. Who is giving? Somebody wants. For example, see, if a force P is acting here, to a point O, it can be this way also, somebody wants resolve the force, see, randomly like this. This is I call direction number 1. This I call direction number 2. To understand. Already over. Angle the force P makes with direction number 1 is alpha 1. I don't call theta. This is alpha 2. Then, remember, this is a general case. There is no restriction. Resolution of a force along any two given directions. There is no rule that they should be mutually perpendicular. It will see. Don't see here now. Then the components are, you should write, this all over yesterday. The components are, see, I will call component P along O1. This is component along O2 equal to. Right, the formula is, if you want, see, this is the point O. If you want component, see, if you want further extend here, this is 1, actually not required, you can see there only. This is your 2, okay. Then, if you want component along 1, the formula is, I will use a black only rate. Given force to be resolved, P into sine of the angle between the given force and other direction. Or simple language, I told, if you want component along 1, this direction, component is force P to be resolved into sine of the other angle. I told so many times, other angle, sine alpha 2. Divided by sine of sum of the two angles, alpha 1 plus alpha 2. This component, same way, if you want along 2, force P into sine of the other angle, sine alpha 1 divided by sine of sum of the angles, alpha 1 and alpha 2. Make a note. Now do one thing. Start. Resolution of a force into two components in two mutually perpendicular directions. That is not this way. Last time, simply this way. You can close it or open it, whatever you can do. Now you can't do it. See, now it should be, see, like this. If one direction is this way, other should be perpendicular to it. There is no rule that this should be horizontal like that. Even tilting also will do. But remember, this should be 90. One by one I will explain for you. Therefore, you write now, consider a force P. See, 1 minute, note. Most important in entire structural engineering. Okay. Consider a force P, which is to be resolved into two components in two mutually perpendicular directions. Right here. Say say, we say xx and yy. Remember, there is no rule that xx, yy should be horizontal and vertical. But once x, whatever way, see, xx, yy, that is, if xx is like this, make a note, yy should be like this, perpendicular. Or, in case xx is like this, no problem, yy should be like this. This is yy. This way we want. Now, what we will do is, it can be done very easily by basic principle. You don't have to use this formula. But to understand, do one thing. See, first, let force P make angle theta. See, now suddenly I am going for theta. Theta with the xx. With the xx. That is, a force, it can be this way also, right now one side, P. This is xx, this is yy, this angle is theta. That angle is theta. Now do one thing, write one more sketch. Then, if you continue, I am writing small because important part is still pending. If you continue, if the force is P here, we told this is xx and yy, never by heart, right side x positive, left side x, that all later. This angle is theta, so naturally this angle will be, I don't have to tell, 90 minus theta. 1 minute. Just checking the camera. Is the display okay or not? Okay, you can zoom and see it also. If problem always, whenever a small sketch given in YouTube, zooming option by finger, you can zoom it. Okay, over. Now, the components will be, see now. The components will be, see, correct, clear. Force P is going this way. One component, it will be like this. This all I will explain second round now. Once everything is over, this I will call component along x, component along y. See now, x equal to, do one thing, use this principle only first. Later I will go for easiest way. This is only to understand that this is general case. Start. Do not bother about easy method. It is force P into sine of the angle, sine of the other angle, sine of what? 90 minus theta. Y means, I can't explain now, see. This component equal to force P into, I want this component, sine of other angle divided by sine of sum of the two angles. Now, if I write sum of the two angles, theta plus 90 minus theta, somebody will be laughing. Sir, you told they are mutually perpendicular. Since the total is 90, that's why if it is theta, 90 minus theta, so directly write sine 90. Okay, those who want write sine of theta plus 90 plus theta, 90 minus theta. You know that sine 90 is 1. And also you know that sine 90 minus theta is cos theta. So this will become P into cos theta. Answer. Now come here. This will be force P into this component, sine of the other angle, sine theta, divided by sine of theta plus 90 minus theta is sine 90, once again equal to 1. So this will be equal to P into sine theta. Remember, this is the result when we consider force P making angle theta with the xx. Therefore, see the result here. Force to be resolved makes an angle theta with the xx. Then x component is P cos theta, y component is P sin theta. Correctly verified. Result I wrote. Now, one more thing required. I will remove this space now because I want one more case. Then I will tell what to do. Next one more. Let, see, right there, one more chance. Or let force P, 1 minute, and upper side, some space I have left for easy understanding. Yes, visible. I should not go further up. I will come further little down. Otherwise, what happens is sometimes, maybe possible, let force P or, see right, or here. Don't see this one now. Once again, P, make angle theta with YY. Same sketch. That is, see, same sketch. Okay, I will do one thing now. I will start from, I can use this one only. Okay, leave it. I will write here. That is, if this is the force P, sorry, this is a point O, this is XX, this is YY, your force P is here, makes an angle theta with YY. In that case, or you can write the same sketch once again as force P, this is theta, means this is 90 minus theta. Okay, now I want some space here. This I will remove, because why? This is known for you. How many times I have to tell? Leave it, remove it. Now, if I continue, down if I continue here, components will be, actually there I have to write, I don't want to use that space. You write, continue further horizontally, because this is somewhere, this will come in the end after everything is over result, not now. So, components will be what I wrote here, components will be as shown below. See here. Oh, if the force going this way, one component this way, P, instead of PO1, I will call PX now. This is PY. See, if the force is this way, this way, this way, that all I will explain later for you, don't worry. PY. PX equal to, once again start, force P, see, if you have this component, force P into sine of the other angle, sine theta, divided by sine, sum of the two angles is sine 90, sine 90 is 1, so equal to P sine theta is the answer. This component equal to force P into sine of the other angle. If I want y, 90 minus theta divided by sine 90. Sine 90 is 1 and sine of 90 minus theta, you should know it is cos theta. Our answer is P into cos theta. Or, okay, now do one thing. Come to final result using the basic approach. See, this already I explained. See here, force P makes an angle theta with YY. I wrote here, where here, see, I'll do one thing now to understand correctly. This all over now. I'll remove this one. That it is much better. See, if I remove all this one now, you should copy all this. You have to copy. I remove means what? Not you don't leave it. Okay. This everything I can remove now. Nothing required. Nothing required now. YY. Okay. Theta with YY. With YY. Now, see here. Force P already explained. Force P makes angle theta with XX. X component is P cos theta, Y P sin theta, already over. Now, force P makes an angle theta with YY. Then we got, just now we got, this is P sin theta, this is P cos theta. Now, this is the result we got. Remember, this result we got how? By using the expression derived when the two directions, maybe at any angle, alpha 1, alpha 2 are the two angles. One of them you put theta, other you replace by 90 minus theta because 90 degrees. Now, this heading I will remove. Now I want something else. I will remove this heading. Heading is in the beginning required. When you start the class, you should know what we are doing. Every full class, it need not be in display. Except in some special cases where the display is continuously required. Okay, now, write the answer. See, for this one, summary in words, I will give little later. Okay. Now do one thing. See now, once again, fresh. Do not use that expression derived where one angle is alpha 1, other is angle alpha 2, because we know that we are doing mutually perpendicular. Therefore, direct answer. See now, or easy approach. Consider a force P which makes angle theta with the xx. Remember, that is here. You should write always, one is xx, other is yy. They are mutually perpendicular. The statement you have to write. This perpendicular. Force P is here. P, this angle is theta. Okay, now, the resolved components right here, components will be, see, one will go, if I resolve here, one component like this, I will call Px, other component here, I will call Py. If ink is little fading, I will change the pen, okay, Py. Now, first make a note. You should write, since Px and Py are components for P, for Px and Py, P should be resultant. This you know it already. P should be resultant. Therefore, do one thing. Come to law of parallelogram of forces. This is a correct approach. Forces. Start. Right. First you consider Px and Py. See, mark a point O here, anywhere here. Mark a point O. Represent Px by a line OA. This is Px. Represent Py by the line OB. You should write, see all the statement in the notes I will write. Here I am dictating. Then they are perpendicular. See, mutually perpendicular. Complete the parallelogram. Oh, you can tell this time it is not a parallelogram, it is a rectangle. Okay. I will call the point as C. Then what will happen is, red color is not there. Usually I use red color for resultant. Right now not available. So, okay, it's available. Not available here. Somewhere here, I got it. Then, still not red. Sometimes this color problem comes, what to do? I might have put it somewhere there. No, not getting. Right time, not getting it. Oh, got it. Then, right here, this is the resultant R. But I already told, sorry, I forgot right here, this is Py, resultant R equal to P. Why? For these two, this P is the resultant. See, this angle is theta, what you used to call alpha earlier. Now remember, if this is Py, this also equal to Py. Not required, you can see here only. Okay, now do one thing. Don't write formula. You have R equal to Px square plus Py square plus 2Px Py into cos theta something. Use property of the triangle. Consider triangle OAC. See here. What is sin theta? Sin theta equal to, I won't write C, if you want you can write AC divided by OA. If you are that much, okay. AC divided by OA. But you know that AC equal to Py and OC by not Y. It is, I was writing for tan theta. So, okay, sometimes it happens. I am not writing tan theta, I want sin theta. Okay. Sin theta equal to OC by AC by OC. Someone is laughing, oh, sir made a mistake. It should happen. I was thinking of tan theta. But actually I suddenly remembered what I want pi px in terms of r. Therefore, that will come later for angle. This is, but what I told is correct. But if I write that way, no use. So, sin theta equal to py by OC. Y means I can't answer. Opposite side by hypotenuse, or equal to py by, okay, right, AC by OC. But you know that AC equal to py and OC is R equal to P. Therefore, you get what? Therefore, we get py equal to py by P equal to sin theta. So, py equal to P into sin theta. And what is cos theta? Right here. What is cos theta? Cos theta equal to, for this theta, OA divided by OC. Oh, sorry, still it is showing AC. Correct. OA by OC. But you know that OA equal to PX, OC equal to P. Therefore, you get, use these two, we get P equal to, sorry, not P, PX equal to. Therefore, we get PX equal to P into cos theta. Okay. Now, go to the result. Go to the result. I won't write one second. See here, same result. Write once again. You write once again. If you want to understand everything, write once again, little later. Go to the result. Therefore, you can tell if a force P is making an angle theta with the xx line, then your x component will be P cos theta, y component equal to P sin theta. Yes, P sin theta, P cos theta. And next, consider a force P, or consider a force P which makes angle theta with yy. Okay, I will change it here once again. You should write once again, not copy this one. Okay, now this is same, Px, Py. Now, this is your theta. Now remember, if this is Px, this also is Px. Now consider this triangle. Consider triangle OBC. OBC. Sin theta equal to Px divided by, sin theta equal to what? BC divided by OC. It is BC divided by OC, but BC equal to Px. BC equal to Px. OC is R equal to P. Or you get Px equal to P into sin theta. P into sin theta. What happened? Sin theta equal to BC by which one? By OC. But Px by R, or Px equal to P into sin theta, correct. P into sin theta. Earlier it was Py. Oh, okay. Earlier it was Py. I got shock. Okay. Px equal to P sin theta, and cos theta equal to, see, for this triangle, cos theta equal to OB divided by OC, but OB equal to Py, and OC equal to P, or your Py equal to P into cos theta. Now go to the result. Or if a force makes an angle theta with y direction, see here, with y direction, then this is components in along xy mutually perpendicular. These both are same. This is when theta with x, theta with y. Then x component, see here, x component is P into sin theta, and y component is P into cos theta. Once again, same result we got. Now, full board, I will see, remember this result we can get either by that expression derived last time when alpha 1, alpha 2 are used. What you have to do? You have to make alpha 1 plus alpha 2 equal 90 degrees. Or simple mathematics, you can get it. This is a result now. Now, full board, I will write the complete summary. Full board I will write it. Now, the final summary. Final summary. Resolution of a force into two components in two mutually perpendicular directions. But usually, instead of word direction, sometimes doubt comes, right side, left side. So what best I will use is, or the best option is, resolution of a force into two components along two mutually perpendicular axes. Why? Plural. Axes, not axes. Say x, x, y, y later. Okay, now, don't see here. Go this side. Let P be the force to be resolved into two components along two mutually perpendicular axes. Say x, x and y, y. So remember, x, x, y, y are mutually perpendicular. Let component along x, x be px, component along y, y be py. Let theta be the angle made by the force either with the xx or with yy. No restriction. Either with the xx or with yy. Okay, now, case 1. P makes angle theta with the xx. See, correct, clear. Theta with xx. Then, this component is P cos theta. This is P sin theta. Case 2. P makes angle theta with yy. Then, y component is P cos theta. X component is P sin theta. Or now, after all this one, come here to remember by words. See, to remember by words. I will not look there. I will tell what I wrote. Component of a force. See, I see there because I want same statement. Component of a force. This is, see, here it hardly matters. You make a note here. We don't mention what? X, X, Y, Y here. Angle theta with which we don't consider. I told general. Right here. This is general statement. Right here. Applicable irrespective of whether you consider theta with XX or YY. Anything. Component of a force along the axis with which the angle theta is measured. See, theta may become alpha later or beta, gamma, that is no problem. Angle. Component of a force along the axis with which angle theta is considered is always force into cos theta. See, simple language. Cos theta is adjacent side. So, with which you measure the angle along that axis is cos. And the other component which is perpendicular to that axis, because why? They are perpendicular. That axis means what? With which you measure the angle, that is any one axis, perpendicular to that one axis is force into sin theta. So see here, once again, here P makes angle theta with xx. So here angle is considered with xx. Therefore, your angle considered or measured with the xx. So xx becomes cos. Yy becomes sin. Here, force P makes angle theta with yy. See, your angle is measured with yy. So yy becomes cos, xx becomes sin. Or, once again, you can mark the angle either with the xx or yy. Your choice. But firmly decide. You should write everything you should write. I told, explain repeatedly. Explain repeatedly. Therefore, cut means later onwards I will not explain. I will tell, go back to class number, I may not remember class number 11, go back to that important class. Therefore, what I told, you decide the angle. Once you consider the angle, you decide with what we want, with the xx or yy. Your choice. Once you decide, or once you consider an angle, with a particular axis, component along that axis with which angle is measured is cos. Other component is sine. Once again, here our force P is make angle considered theta with x-axis. So x-axis is cos, y is sine. Here force P makes angle theta with y. So y is cos, x-axis is sine. Lastly, firmly decide with which axis we want to consider the angle. With which axis you consider the angle is cos. And the perpendicular one along other axis is sine. Angle theta with x cos, y sine. Angle theta with y cos, x sine. I told 3 times. Now I cannot tell. Later when I solve a problem, I will write, see, 75 cos 30, 75 sin 30. Somebody may comment, not explaining properly. I will tell, reply the comment, not explaining properly, not concentrating or studying properly. It is your problem, not my problem. No dedication, not interested, and once in a while coming to the class and going through and commenting. Go through all the classes, starting from beginning. Let me see then what doubt will come. Now I will tell something for you. See, I will tell something. I will sit and tell. I don't want to stand now because from morning I am taking non-stop class. Recording were there, and just earlier I finished a class. See, you may not see my face now. I will dictate something. Then I will write on the board. Sometimes in a question or in any case, angle may be given with the x-axis. Okay? Angle may be given with the x-axis. Sometimes it can be given with y. Okay, I am standing here only, leave it. It can be given with y. Anything is possible, but remember they are mutually perpendicular to each other. Then you can use the angle whatever way given. If they give the angle with the x-axis, and if you use that angle, x is cos, y is sine. If you use the angle with y, then y is cos, x is sine. So again I am telling same thing 100 times now. With which you consider the angle, with which axis you consider the angle, that component is cos, other is sine. But I always want simplified procedure. I know students' confusion. Sometimes student will tell, last time you took me horizontal as cos theta, sir. Now this question, you took sin theta. Sir, confusion. See, people are there. No, not few, majority are there. Maybe around 20% students can understand clearly. If the angle with x taken, x is cos, they will understand. But what about remaining 80%? I know student mentality. Confusion comes. I always take the class so that those who attend my class and study thoroughly, they are completely free of confusion. So far, I never concluded a problem and then asked in the class, any doubts are there? I never ask. See, in my all nearly more than 40 years, 42 years, after anything, I never ask students any doubts. No, because doubts are not there. There is no doubt clearing from me usually. Sometimes parents, when they admit the student, they will tell, if he gets doubt, will you clear or not? I will tell no. They will get a shock. I am asking my ward to join a class. He is telling not clearing the doubt. Then I will tell them, it is not arrogant way of no. Doubt will be cleared if at all doubt comes. Let us see how doubt will come. Let him be serious. Let him show dedication. Every concept I tell, how much concept I know, how much I tell, what way I tell is left to me. Then let me see doubt. So far, in around more than 42 years now, not a single person asked one doubt in the class. Maybe some other doubt he might have asked. Some sort of, that is that way, what happens, sir? But what I solve on the class, not a single one asked, sir, one doubt. No. But they may ask, sir, one technical doubt they may ask. But as far as the steps are considered, no one has asked a doubt so far. It's a record. No doubts will come. That I can tell with confidence. Therefore, what I will do now is, I will stick to one principle. When you consider the angle with the x is, see, this may be, for some people, this may be boring. What to do? I should tell everything clearly. Listen correctly. Even if you feel he is telling boringly, repeatedly, remember, come in front of me, I will show you your level. So I will tell the students, whatever I tell repeatedly, listen. It is for your benefit. They will agree. Okay. So sometimes if you consider the angle with the x, then x becomes cos, y becomes sine. If you consider the angle with y becomes cos, x becomes sine. Why all this confusion? I always want easy approach. So once I explain this with the example, then I will tell in the class, now onwards what you do is, no confusion. You always consider angle with the x. I won't tell horizontal, with the x. Some will ask, sir, if they give angle with y, I will ask, what is the angle between x and y? Sir, 90 degrees. Suppose they tell angle with the x is 30 degrees. Okay, thank you, sir. Suppose they tell angle with y is 50 degrees. With x, sir, 40. Then why you are asking me? Oh, sorry, sir, confused. Okay. Not doubt, actually confused. So, irrespective of whether they give angle with the x or y, in my class, I always want students to understand and get a grip. Those who got capacity, do whatever you want. But I will always give a warning. You try your own thing. Later, tomorrow, if you make a mistake, not following my instruction, you are only responsible for it. They will tell, yes, sir. Sometime it happened. Sir, by mistake, sir, I took the wrong angle and I took the angle with vertical and I took vertical as cos, sir. Why? Sir, because habit. Then why you took the angle with vertical? So they told 50 degree. Take 40 degree. Yes, sir. I will never make the mistake once again. Therefore, what I will tell, I will write in the board now. What I will do is, I will always consider angle with x. That is horizontal, usually horizontal. Therefore, permanently, you don't have to bother. X is cos, y is sine. If they give angle with the y, you find the complementary angle. If they give angle with the x, say 20 degrees, thank you. If they give angle with y, say 75 degrees, okay, with the x, 15 degrees. Take 15, nobody will object. Okay, that I will write in the board, but before that, first I will give an example for resolution, then I will go for that final statement, final verdict I will tell, so that it is for your benefit. Now write one example. Make a note here, one note. You should write note. In this example, see, a force system is given. Question is, resolve all the forces and get components along x and y. Further is not required. Summation, resultant, all we will do later. Now, make a note. For some of the, see, for these two forces, angle given is with the x. For these two forces, angle given is with y. What we will do is, we will consider the angle whatever way given. That means, this is not the practice we are going to do later. Later what we will do? Right here. Right in this example, we go to basic concept. Someone will tell, if I take this 70 degrees here, why 20 given? Can't use 20? I will tell them I can use 20, but people are there who got difficulty. If you got capacity, take whatever you want. See, harsh answer. If somebody comments, not that for me it hardly matters. When I look at the sketch here, I can make out this is cos, this is sine. If for this angle, here, by looking only I can make out cos and sine. I won't get confused. I don't have to by heart. Take the angle, always, there is no always for me. Whatever given, same way. But I am teaching for you. You are learning. Therefore, right here. So what here we will solve or find components as per the given angles. But later, After one summary I am going to give, after this example is over, one final, not warning, instruction or something I will tell for you, a hint, or you can call easy method I will tell. Then onwards, we will consider angle for all the forces with xx only. So therefore, this is only for understanding. Later, second example, I will take same example, same sketch I will take, but then what I will do? I will solve it in the most popular way. Okay, start. First, simply, briefly I will tell. Consider 70 Newton force. See, passing to the point O, 70. Make a note. Given angle 40 degree with xx, therefore 40 degrees. Angle given with the xx, therefore x becomes cos, y becomes sine. Sufficient. You can make out now. Multiplying all, you do it. So that all I won't waste time. Okay. Now, 30 Newton force. See, in the question they told 20 degrees with yy. Okay. Therefore, consider 20. Then 20 is with yy. So y becomes cos, x becomes sine. Consider 70 Newton. Sorry, here 25 Newton. Here angle 28 degree given with the x. Sorry, x. Therefore, x becomes cos, y becomes sine. Calculate. Consider 40 Newton. Here angle 15 degree given with y. Therefore, if I use 15 degrees, y is cos, x is sine. Furthermore, if I explain, waste of time. 30 into cos 20, y won't calculate. Okay, now I won't take photo, I will take a photo of this one. Because later, same example I will take and we will find the component. The way it will be very easy for you, no confusion. Before that, I will give one summary here now. Then I will go for that one. Okay, 1 minute. Now, most important, see, right here, for our course, most important. Right. I will dictate, you write. In a box, you write here. Those who are serious, they will write. Those who are not serious, I am not bothered about them. Right here. It is already decided, or we already confirmed, or we got result that with which axis you consider angle, that component is cos, and the other perpendicular direction component is sine. Force into cos, force into sine. Sometimes angle can be given either with xx or yy, or in structural engineering with horizontal or vertical. Even inclined also possible, I will come to later. At a time, one thing. If we consider the given angle as it is, we should be very careful. We should correctly observe that angle is given with the xx or yy. Oh, xx given, therefore x is cos. Oh, yy given with yy, y is cos. Yes, it is not difficult. I am dictating, you are right. Half page it will come now. In the notes I will write everything. But sometimes in a hurry, time trouble, given angle we will use. It may be given with xx, then no problem. X is cos, y is sine. But sometimes the angle may be given with yy. In a hurry, we will take that angle, and by usual practice, we will write x cos, y sine, gone. Therefore, it is always better and avoid the complete confusion if we always consider angle with xx only. In engineering mechanics, xx only. Later in structural engineering with horizontal, I will write. Then we do not have to bother about angle made, etc., sine, cos, nothing. You can close your eyes and tell the answer. Then 100% x component is cos permanent, y component is sine. Sine into 4, sine cos sufficient. So remember, once again I will tell, always consider the angle with the xx. Then without confusion, x component cos or structural engineering horizontal cos, vertical sine. Over. I won't repeat. Go through the statement again. In a book you write 3-4 times if you want. But one warning, one serious warning. Suppose this is xx, a force given here. For example, it is given this is 150 degrees. They will tell, yes, angle given is xx, 150. Gone case. If you take 150 degree angle here, it is not wrong, but you require corrections. I will ask students, do you want correction? No, sir, we want simple. Therefore, one very serious matter, you consider this angle. Or the serious warning is that when we consider angle that is theta, always consider, I will not tell again and again, consider it with, I won't tell again and again, nearest xx, or simple language, you see that your theta is always less than 90 degrees. Never and never consider theta which is more than 90 degrees. Never consider theta which is more than 90 degrees. Never consider. Warning. If you consider what happens, I will tell you later. In the class I will tell. Mistake, actually not here. One more series of class I am uploading. Common mistakes people commit and how to rectify it. Somebody may tell, who is this person to tell the mistake? Yes, I am an experienced person with the solid grip on structural engineering. People who know me will tell, my purpose is to educate those who are making mistake. At least I will tell, now onwards, don't make the mistakes. Not one. So many, more than hundreds are there. Some of them are very delicate mistakes. I will tell everything in a special series of class. Here also I will briefly explain. And purpose is not to insult or degrade anybody. At least purpose is, see, you are making mistake. Don't make the mistake. Learn from me. And now onwards, whether you tell you learn from me or not, your choice. That is left to you. But people usually will agree, yes, and taught us. But at least correct it. So society, don't give wrong answer. Okay, that is very important. Okay, now I will take 4 cases. See, just imagine right here. Now to understand correctly, consider here. From a point O, force going is P. See, theta, do not consider this theta. See, nearest x theta here. Then, see here, if this force is going this way, x will go this way, y will go this way. Suppose you got confusion, what to do? Take a pencil, see here. When the force goes this way, see, if you mark this way, then only this P will be resultant. See, this way. You can't, for this force, see, for this force, sometimes people ask, sir, why it is right side? You cannot mark this as this way. If it is that way, the force will be like this. So, see here, this force goes this way. If you want, pencil mark. See, going left side and going upward. Here, going left side but coming down. This is very elementary. Right side and down. And now, see, here, nearest angle theta with xx. Nearest theta with xx. See here, nearest theta with xx. Nearest, not this angle. Nearest theta with xx. All the 4 cases, theta is less than 90. Now you can see the result there. You don't have to bother. Cos sine, cos, x cos y sine, x cos y sine, x cos y sine, over. That's all. So this way you do it. Okay, now what example I just now told, I took a photo of that one. I will once again consider the example in the way which is easy for you and what we will do in future. Anything else required? Nothing. Anything important, I will tell you later. If I find anything important. Okay. Now, closing part of this class. Most important, never forget. Once again, same example once again, but this time without confusion, right? Without confusion for you, or right here. Without confusion means correctly decide whether angle with the x or y, which is cos, which is sine, nothing required. What, right here, put the sketch first to the point O, force system given question. Resolve along x, x, y, y. First make a note. For two forces, they given angle with xx. Other two forces, angle with yy. And every angle given is less than 90. Therefore, no problem. If they give more than 90, I will tell you next time, not now. Okay, now, when you go for resolution, you stick to one concept. What, see, right here, red color, right here. When you go to resolution, whatever way they give the angle, you consider the angle with the nearest xx and also nearest xx. That is, it should be less than 90. Okay. Then see here, 70 given this way. So resolution, this I told you, it will be like this. This is pencil mark if you want. This is pencil mark, I already told you. This is not important. Important, but later. Okay, now start. 70 given, 40. Oh, right here. Thanks. Thanks, because we want angle with xx. They told with xx. Therefore, over 70 cos, 70 sine. Same as last time answer. 30 given this way. Right here, 20. Make a note here. No thanks. Right here, no thanks. No thanks. You give me angle with vertical, you are trying to confuse me, no problem. I know what to do. 30 given, 20 with vertical, I know mathematics. This is 90, if that is 20, I know it is 70. Okay, right here. This 70 is calculated. Not a rocket science. Somebody in the high school will tell the answer. Okay, then. Now angle is to xx, therefore no confusion. See, cos, sine. Here, 25 this way. Thanks. Why thanks? Given with horizontal, therefore cos, sine. 40, no thanks. Tell here, no thanks. You give it vertical, I know what to do. If it is 15 degrees, this will become 75 degrees. This is 75 degrees calculated. Remember, calculated. Cos, sine. Sometime I will, class is over now. I will ask a trapping question. If you are in front of me, 99% people will get trapped. What I will tell in the class is, see, here angle given with horizontal. Here angle given with vertical. Last time you took with vertical, but this time to avoid confusion, even though angle given with vertical, we took horizontal. Therefore, in the class I will ask, what will happen is, compared to last time result, x component will become y and y component will become, x. What is this nonsense? Whatever way you take that, they will fall trap. I will tell, last time this was y, this was x, yes or no? Then slowly one by one we will tell, sir, sine, cos are interchanged, sir, same answer. Then why you told first yes? Sir, you trapped us. I got a very good technique of trapping. I will see that people make mistake. Purpose of the trapping is not to enjoy. Remember, by trapping students, what enjoyment I can get? Purpose of trapping is they know it, my students. I will always push them down and down and down. Why? To motivate them to come up. I will always tell them, if somebody makes fun of other, tries to tap, find mistake everywhere and enjoys it, he is called sadist. I will ask them, do I look like sadist? Sir, no sir. Then why I do all these things? Sir, we are doing all this so that we should not make that mistake later. It's a lesson for us. Yes. Whenever you are trapped and repeatedly trapped, then you learn. There are so many people who will tell they are very, very senior now. See, maybe 10 years below me. Those who are almost coming, they finished almost very highly experienced in structural engineering. Even now they will tell, sir, because you trapped us repeatedly, I got perfection, sir. Yes, that's why the trapping is not for enjoying. I am not a sadist. Trapping is to see that you will not make the mistake. This will, in the recorded class, it is not much possible. It is possible only in either online live class or offline class. There I enjoy. Enjoy means not that enjoyment. Enjoy means what? Somewhat. It is not enjoyment. Trap and then teach them. Okay. Go through last warning for you. Those who want to learn complete structural engineering from me, every class, everything go through and make a note and perfectly study and show full dedication. Further, left to you. Thank you. We will meet in next class.